Kim, floor is yours.
Good morning, everyone. Rector Magnificus, professors, students, distinguished guests, ladies and gentlemen. I shall try to speak on this subject. I hope you will bear with me. I maybe won't answer the question, but I hope that I will stimulate you all to think about the question and maybe explore into the future. Let's see. I will begin with climate change and then get into the more precise questions about are we equipped and how should we equip ourselves. Last week there was an article, a portrait of me in Der Spiegel, a German magazine. It described me as an eccentric. And I don't know why. I quarreled with my wife and she says, yes, you are eccentric. We'll see what you think in a few moments. When we discuss climate change, we have many questions to look at. The picture to the right could be illustrate the Ice Age. The picture to the left could illustrate the time of the dinosaurs. The picture to the left is in South America today. The picture to the right is Svalbard today. We have both right now at the same time on the planet. And whenever we discuss change, when and where are very central elements. And this is something that is confused very much in both scientific debate and also public debate. 100 million years is very different from yesterday. When I was a junior scientist, the question was, is climate changing and are those changes unique? I want to distinguish that from the question of what is causing the changes. And again, this is something that is confused in literature very often, in particular in mass media. It is changing, therefore it is man, or whatever. There are many reasons for changes around us. The third point here, other human-induced changes. We discuss climate change, but we are doing a lot to the planet at the same time. And the combination of different changes is very difficult to separate. Temperature is rising, farming is increasing, fertilization is increasing. There is a lot going on. Society asks of us as scientists to answer questions on what are the effects of these changes. And there the interdisciplinarity comes in very quickly. What are the effects on ecosystems, but also on society itself? Buildings, roads, whatever. Infrastructure. And of course, the combined effects are really intriguing. The polar bear on Svalbard is under pressure because of climate change. The polar bear on Svalbard is under pressure because of pollutants. But if it is doing anything right now, it is increasing in numbers because we stopped hunting them in 1973. So we have all these different pressures with different timescales. And we as scientists must separate those. I will not have time to talk very much about models, but a little bit. These are the tools we use to say something quantitative, systematic about the future. This is a picture from a newspaper in Norway recently, and it shows how the landscape is becoming overgrown. This has very little to do with climate change. It is in a rich country. They are not bothered to take care of the small fields far away from the roads. and very quickly things grow over. It will take hundreds of years before Svalbard looks like the picture to the right. And these are very dramatic changes on the short time scale. Carbon dioxide is increasing in the atmosphere. These measurements were begun in 1957 in Hawaii. The reason they began measuring there was they suspected that there were indications that humankind was changing the atmosphere. And already after 1 year, one saw that this was so. We have known for more than 60 years that humans are changing the composition of the atmosphere. The physics of climate change was published in 1896. It was presented at a Nobel dinner in 1895. But the article looks like so, and we can look on the influence of carbonic acid in the air upon the temperature of the ground. We have known for more than 120 years that carbon dioxide influences the temperature of the ground. Svante Arrhenius got it right, a little bit by luck, but essentially the sensitivity was correct. We also know that the temperature of the planet has gone up. It went up in the 1920s. There was a long period of time when it stood still, and the last 40 years, temperature has increased. But if you remember my first slide, temperature change does not mean that we know why it changed. We know a little bit more. And let's see if this works now. The blue temperatures, or the blue are cold, the orange-red are warm. In the 1930s, the Arctic warmed up, but then it cooled off again. But if you bear with me towards the present time, I think you get an impression, at least I do, that something very different is happening the last 40 years. Okay, sorry. All right, I will have to do this in the blind because I don't see the slides coming forward, but we'll see what happens. I'll go to Svalbard to have a closer look at climate change in Svalbard. And we can there see temperature rise. The bottom curve, the gray, is the global average, and the orange-red is the Arctic. And you see towards the end here, I'll have to do it this way. All right, I have trouble with this because I'm colorblind and I don't see the dot myself. The red here is the Arctic, and you see that it is much steeper than the gray, which is the global average. The Arctic is warming twice as fast as the rest of the planet. And if you look at the top half, which shows the development, particularly in 2016, whoops. You see that the reddest area is right over Svalbard. So in the Arctic, we have the most warming, and Svalbard and yet Franz Josef Land are the areas with the most warming. If you look at the temperature in Svalbard during the last year, you see the black curve here is what has been defined as the normal, and you see that the temperature, the blue and the red curve, which was the measured temperature, has been above the black one for the entire year. And in fact, in March of this year, we had 100 months in a row where the measured temperature was above the normal temperature. You can also see that the winter period is much higher than the black curve, whereas the summer period is only a little bit above the black curve. The wintertime temperatures in Longyearbyen have increased by almost 10 degrees average during the last 30 years. And when we talk about 1.5 degree goals, we are very far away from that. The landscape, we have pictures like this from Hornsund, we have pictures like this from all over Svalbard. You can see this mountain 4 times. Let's see, there, 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 there. And if you rest your eyes to the left, to the right, or in the middle, you see a landscape in clear change. In fact, the bottom figure here, this glacier has moved back 1 kilometer since this picture was taken in 2010. This is an article from 1922. And it might be hard to read, but I have blown up the first paragraph. And it says, the Arctic seems to be warming up. Reports from fishermen, seal hunters, and explorers who sail the seas about Spitsbergen and the Eastern Arctic all point to a radical change in climatic conditions and hitherto unheard of high temperatures in that part of the Earth's surface. And certainly the words radical and unheard of could be found in any tabloid paper also today. Climate, the point of showing this is that climate has always changed, will always change, and for us it is important to understand what is natural and what is created by humankind. So, here I will talk a little bit about models. The black curve here is the temperature record, and you see that it goes up in the 1920s, 30s, and the last 40 years. We can study this with models. And what are models? Models are simplifications of the world. In medicine, a pig could be a model for a human being. This is a model airplane. Now, with models, we can do experiments that you might not want to do otherwise. I will make an experiment to fly with 1 wing. I don't know, you can fly with LOT for half price, only 1 wing. Who wants to join? Let's see what happens. You can expose surprises with a model. I think many of you hypothesized that it would not fly at all. Now, if we run our climate models with carbon dioxide, with the variations in the sun, we get this family of curves. It follows the measured temperatures quite well. If we now take the same models and take out the carbon dioxide, keep the atmosphere constant, we get this family of curves. And the curves, the last 40 years, are not reproduced by these models. The temperature increase that we have measured is not reproduced unless we have CO2 in the atmosphere. Human-induced CO2. I call these plots crocodile plots. When I try to explain this to politicians so they might remember, it opens up like the mouth of a crocodile over to the right. The Arctic is changing, Svalbard is changing. The red arrow here is what popularly might be called the Gulf Stream. It is warming up. My institute has been measuring the temperature of that water, and over the past 50 years, the temperature has gone up by 2 degrees. And that has manifested itself in a clear Atlantification of the western coast. We have warmer waters, we have new species, we have no ice on the fjords in the winter, and many other changes. These were some students, like yourselves, that were UNIS students, in fact, that discovered a new species 2 winters ago, a helmet jellyfish in this case. But we have many other indications of that. The warm water also changes the ice. So the white here is old, thick ice, and if you look to the left, the entire Arctic was covered with 7-year-old, very thick ice. And today, the Arctic is covered by much thinner ice. The whole system has changed. Now, these before-after pictures, you have to be careful with. This is a well-known before-after picture where some interpret the picture to the right to contain more people than the picture to the left. And actually, 3 months ago, it turned out that these pictures are cut. In reality, it looked like so. And I say to you, as students, professors, rectors, ask questions, be critical, always. There is always something more behind it. All right. We run our models and we produce pictures like this. This is for permafrost, ground colder than 0. And you see that the areas decrease towards the right. And then you ask, and you can make narrative stories that this is big, this is dramatic. But we have to look at it in perspectives. This is a wolf. Wolves are controversial. Wolves are formidable animals. And their distribution on the planet is like so. And this map, there are 2 things that I want to point out with this map. The wolf exists in northern Greenland. The wolf, the same animal, exists in southern India, in some of the coldest places and some of the warmest places on the northern hemisphere. There is no climate scenario, there's no climate change that the wolf could not cope with. The other point here is all the red areas are places where the wolf used to exist, but humans, through other decisions than climate, have killed them off. So that again, before climate has made any influence like that on the wolf, it will take thousands of years. They can withstand anything. This is the song of a narwhal. Narwhals are opposite to the wolf, very sensitive to climate. The distribution of the narwhal is right along the ice edge. And if the ice edge disappears, the narwhal loses its habitat. So, is this big or small? For the narwhal, it is very big. For the wolf, it means nothing. So we have to have perspectives on every step. Arctic climate change is of global significance. It changes weather patterns in the world. It leads to sea level rise. It leads to shipping and new shipping routes and new access. It influences food security through the fish in the ocean. And it influences global heritage. If the polar bear disappears, we have all lost something. I pose it that we are moving into a realm of decreased predictability because the changes are so rapid. The Arctic is becoming warmer, wetter, and wilder, but the decreased predictability is something that society and all of us need a strategy against. So how to meet the unpredictable? Well, you have to have as many alternatives as possible open ahead. And that means, to me, it means to have diversity. And I have a diversity tie on today with many frogs. Diversity in biodiversity, extreme environments are important. Ecosystems, the Sahara Desert, the Arctic, the Antarctic are important to maintain diversity, but it is also human diversity, indigenous people, it is cultural diversity, and above all, scientific diversity, interdisciplinarity, caring for knowledge of all kinds. The Arctic, when I was a junior scientist, people suggested that the Arctic was simple, and therefore it was a rapid career if you went into the Arctic. Many years later, it was not so rapid, it was not so simple either. There are many different processes that we have to understand. And to do that, I want to pose the following questions. Is there life on Mars? How do we explore that? We will probably not send biologists to catch butterflies. We will think spaceships, we will think innovation, we will think high tech. But we won't send scientists either. We will sit down and think. And just, is there life on Mars? You can look at structures maybe with a spaceship, but what are the criteria for life? It is not very simple at all. You need, these sausages certainly look like some of these fossils. There was a project on Svalbard where they tried to explore how to do it, and it was high-tech indeed. And high-tech is, of course, something that we discuss also for Svalbard. Think of Eastern Svalbard. Think of Svalbard as Mars. That's when we need innovation. If you just go out and catch some insects, you're doing it the old way. We need new ways. We need to inspire each other for that. I was in India some years ago, and the minister was talking about the future, and this made me think, well, if India is thinking about high-tech and we in small Norway or Sweden or even Poland is small compared to India when it comes to human resources, we have to be a little bit more clever about what we do. This is Arizona, a road in Arizona. This is high-tech in Arizona. If you want to drive straight, a Ford Mustang is great. This is Rome. Rome is always confusing. And this is Italian high-tech. And excellent in Rome, but hopeless if you want to drive across Arizona. And try to drive a Ford Mustang in Rome. It will probably kill you. This is Hornsund, or outside Hornsund. What is high-tech in Hornsund? What should we be thinking about there? And that's up to you to have imagination. And there is somebody right in the middle of the picture, too. So how to excel? Well, we have to pay attention for competitive advantages, and we must seek those both in where we are, Hornsund, Longyearbyen, Katowice, but also who we are. We have very different talents, each and every one of us, and we must foster them. All right, this is a busy picture, but it is a question of how to drive developments of observational systems, but in particular, the need for new technology, new logistics is what I want to highlight. There was talk about interdisciplinarity before. We need all sorts of interdisciplinarity between science, scientific fields, but also between logistics and between science and engineers, new detectors, new technology. And so I suggest we need a new type of interdisciplinarity, not only between the silos, but also between many other fields. Scientists and engineers. And between scientists and logistics operators. So open your minds, be wider than just between silos. We have to be really innovative in all sides. It can be overwhelming. And there was Lord Kelvin said in 1900, there is nothing new to be discovered in physics now. You can only do more and more precise measurements. So this was 1900, but just 5 years later, special relativity theory came, and a few years later again, general relativity appeared by Albert Einstein, already mentioned today. There is always something new to discover, even if it looks overwhelming. Albert Einstein later became more of a philosopher, and he was thinking about ideas. We need ideas. We all need new ideas. A new idea comes. A new idea comes suddenly. And it comes in a rather intuitive way. And intuition is the sum total of earlier intellectual experience. Study courses, any courses. Knowledge in itself is important and can be used in ways that none of us can think of. I cherish knowledge everywhere, anytime, any knowledge. And maybe suddenly, I usually don't get new ideas in my office. I sit on a rock somewhere looking at a bird or whatever, and then, yes, let's do it. Education, you are bound to push a PhD education. I'm not at the university, I'm at the Norwegian Polar Institute, but I do believe education is quite profound. Together with critical thinking, respect for different views, and dialogue, we can make constructive use, and we can pursue better solutions. It empowers people to fulfill and enrich themselves, and as well as their cultures, through the abilities and opportunities that education gives them to influence their own futures. You have your future in your hands. And education is the foundation of democracy. So I will stand up for it anytime, anywhere. And I hope you will too. So what should we do? What should we do with a crocodile? I get inspiration from this jaguar. The problems are overwhelming, the problems are huge, but if you're determined and really want to, a crocodile is not a problem. I hope you will bite it in the future. I've given you some small pictures of what science needs, what science we should do, and the question of the challenges that we have, and the need for interdisciplinarity and a broader interdisciplinarity, and an open mind, and suddenly there will be a new idea. I want to close with this picture. A walrus singing. This walrus is on a piece of ice in Kongsfjorden outside Nyålesund. It cannot rest like this anymore because we do not get this type of ice there anymore. It is contemplating, and suddenly there might be a new idea. What happened now?